Today we are going to discuss how to compute for the deflection of beams using the double integration method and moment area method. In this problem, we are asked to determine the deflection at midspan. Looking at the diagram, we have here a simply supported beam with a 6 meter span and a 12 kilonewton concentrated load at the middle. The first step to get the deflection is to get the reactions of the supports. Solving for reactions, summation of forces along the horizontal is equal to 0, right side positive. Since nag-iisa lang yung horizontal forces natin and walang ibang kumukontra na force, that means yung value niya is 0. Next is summation of moment at A is equal to 0, clockwise positive. Yung 12 kilonewton na load natin multiplied by 3 meters, which is yung distance niya, distance between the load and yung sa A, minus reaction at B multiplied by 6 meters, which is yung distance niya din papuntang A, equals to 0. Negative kasi pa-counterclockwise. And pag kinompute, reaction at B is equal to 6 kilonewton upward. Since positive, that means tama yung assumed na direction natin for reaction B. And summation of forces along the vertical is equal to 0, upward positive. Ilalagay natin yung nakuha nating value ng reaction B, which is 6 kilonewton minus 12 kilonewton na load plus reaction at A, vertical is equal to 0. And makukuha natin na reaction ng A, vertical is equal to 6 kilonewton upward. So, next step is ikakat na natin yung beam arbitrarily sa part na to. And magiging ganito yung diagram niya. Ika-copy lang natin yung mga forces dito sa left part nung nakat na beam. Since hindi natin alam yung distance ng from A until dun sa nakat na part ng beam, i-indicate muna natin siya as X, as well as yung distance ng load hanggang sa nakat ng part na beam. And indicate natin siya as X minus 3. After that, magmo-moment na tayo dito sa part ng cutted na beam. Summation of moment is equal to 0, clockwise positive, 6 times x minus 12 x minus 3 minus m is equal to 0. Pag i-arrange natin siya, magiging m is equal to 6x minus 12x minus 3. After that, sisimulan na natin yung double integration method. Using yung formula, EIY prime is equal to m wherein EI is constant. So, substitute lang natin yung nakuha nating value ng m. And makuha natin is EIY double prime is equal to 6x minus 12x minus 3. Pag in-integrate natin siya, EIY double prime maging EIY prime 6x over 2 maging 3x squared minus 12 over 2 maging negative 6 x minus 3 squared. Dahil nag-integrate tayo, magdadagdag tayo ng constant which is C1. Then mag-integrate tayo ulit. EIY prime maging EIY 3x squared over 3 maging x cubed minus 6 over 3 maging minus 2 x minus 3 squared x minus 3 cubed plus C1x plus C2 kasi nag-integrate tayo, magdadagdag ulit tayo ng constant. Dahil dalawa yung unknown natin na value, gamit tayo ng boundaries which is kukunin natin sa support ng beam. First, hanapin natin kung saan nakalocate yung hinge support natin which is located at x is equal to 0 and y is equal to 0. Pag sinubstitute natin siya dito sa equation na to, wherein x is equal to 0 and y is equal to 0, makukuha natin na value ng C2 is equal to 0. And next is yung second na support which is yung roller natin. Roller support located at B. And located siya sa 6 and y is equal to 0. Pag sinubstitute natin siya dito, wherein C2 is equal to 0, makukuha natin is EI y is 0 is equal to 6 cubed minus 2, 6 minus 3 raised to 3 plus C1, 6 plus 0. Makukuha natin value ng C1 is equal to negative 27 kilonewton meter squared. Pag nilagay natin itong value ng C1 dun sa equation, makukuha na natin yung deflection equation which is EIY is equal to x cubed minus 2x minus 3 raised to 3 minus 27x. Since yung required is the deflection at midspan, isa-substitute ulit natin yung x is equal to 3 which is yung midspan dun sa deflection equation. EIY is equal to 3 raised to 3 minus 2, 3 minus 3 raised to 3 minus 27 times 3. Since 3 minus 3 is equal to 0, makakancel to. Magiging value ng EIY is equal to negative 54 kilonewton meter cube. Negative value kasi pababa yung magiging deflection. And pag in-arrange natin, EIY is equal to negative EI deflection, magiging EI deflection at mid-span is equal to 54 kilonewton meter cube, or deflection at mid-span is equal to 54 over EI kilonewton meter cube.